Hello, my name is Alfonso Bernal. The topic of this video is exponents. In this video, we will review the power rule for exponents. So let's get started. Let's review the power rule for exponents. The power rule for exponents says the following. For any non-zero real number b and positive integers represented by the letters m and the letter n, we can say the following. If we have a value b raised to the power of m in parentheses, which is then raised to the power of n, then this is equal to the value b raised to the power of m times n. In other words, we keep the base and we multiply the exponents. And this is the power rule. Let's look at some examples. Suppose we have 7 raised to the power of 3. In parentheses, raised to the power of 2. Using the power rule, this is then equal to 7 raised to the power of 3 times 2, which is then equal to 7 raised to the power of 6. In turn, this represents the repeated multiplication of 7 6 times. If we evaluate this product using a calculator, this is then equal to 117,649. Let's look at another example. Suppose we have the variable z raised to the power of 3. In parentheses, raised to the power of 5. Using the power rule, this is then equal to the variable z raised to the power of 3 times 5, which equals the variable z raised to the power of 15. And that's the result of the second example. So let's practice the concept of the power rule, which says that when you have a base b raised to a power m, which is then raised to another power n, then it's equal to the base b raised to the product m times n. So let's evaluate the following expressions. The first one reads, the variable d raised to the power of negative 5, in parentheses, raised to the power of 3. Using the power rule, this is then equal to the variable d raised to the power of negative 5 times 3, which equals the variable d raised to the power of negative 15. This equals 1 divided by d raised to the power of 15. This expression is obtained using the negative exponent rule. If you're unfamiliar with the negative exponent rules, please review the video titled The Negative Exponent Rules. So this is the final result of the first expression. So now let's look at the second expression, which reads y raised to the power of 7 divided by y raised to the power of 2. In parentheses, raised to the power of 3. We will start by simplifying the inside of the parentheses. So then, inside the parentheses, we will write y raised to the power of 7 minus 2. This new expression is obtained using the quotient rule. If you're unfamiliar with the quotient rule, please review the video titled The Quotient Rule for Exponents. Continuing with this expression, inside the parentheses, We will then write y raised to the power of 5, which is then raised to the power of 3. And now, using the power rule, this is then equal to y raised to the power of 5 times 3, which equals y raised to the power of 15. And this is the result of the second expression. So now let's look at the third expression. The third expression reads x raised to the power of negative 1 times x raised to the power of negative 8. This product is in parentheses, and it's raised to the power of 2. We can start by simplifying the inside of the parentheses. This is then equal to, within the parentheses, x raised to the power of negative 1 plus negative 8. Note, we obtain this expression using the product rule for exponents. If you're unfamiliar with the product rule, please review the video titled The Product Rule for Exponents. Continuing with this expression, this is then equal to, within the parentheses, x raised to the power of negative 9. Now we can use the power rule. Using the power rule, this is then equal to x raised to the power of negative 9 times 2, which equals x raised to the power of negative 18. In turn, this is then equal to 1 divided by x raised to the power of 18. Note, this expression is obtained using the negative exponent rule shown. Again, if you're unfamiliar with the negative exponent rules, please review the video titled The Negative Exponent Rules. And this represents the final result of the third expression.